Alright, so now that we have a physical representation of what our players will be in the world, let's talk about how we can make it do stuff. So, really on a high-level conceptual level, games are really just player inputs. Player inputs some kind of data through their controller or keyboard or mouse, whatever they have. They're going to be giving some kind of input into the engine. The game is then going to interpret that information and create some kind of behavior as a result of it, and then it's going to send video information and audio information back to the user to be displayed on their monitors and other speakers. So really, all a game is a machine for handling user input and displaying output. So in order to have Unreal interpret our player input the way that we want it to, there's really two things that we need to do. The first thing is we need to define our possible inputs, and we're going to do that by changing a setting. So up here in the settings menu, under project settings, if you go about halfway down the engine section, you're going to find a setting for input, a setting screen for inputs. Now, Unreal Engine can handle two different types of inputs. One of them is an action. And an action is just a fireable event that happens when the corresponding key binding is pressed, or corresponding input is pressed. So you press a key down, that's an event. You lift the key up, that's another event. That both can be mapped to a particular action mapping. An axis mapping is going to be an assignment of some value, typically between -1 and 1, that's going to be able, where you can take that value and define some logic based on the value between 1 and -1. Now, if you were playing with sort of an analog controller that had a thumbstick, you would have two axes on a given thumbstick. One of them would be forward and back, and if you press the thing all the way forward, then that would be usually outputting a value of 1. You push the thing all the way back, it would be putting out a value of -1, and if you let it go and it kind of went back to the middle, then that would be putting out a value of 0. And so then the other axis for that same thumbstick would be left and right, and it would be the same. If you go to the right, it would give you usually +1, all the way to the left would give you -1, and back in the middle would give you 0 in that axis. And the reason that Unreal Engine handles axes instead of just outputting a digital 1 or 0 for all things, like you could in theory make your characters move forward and back or look up and down just using actions, but that would be limiting in terms of the control schemes that you could use for your game. And so it handles by default actions and axes both. So let's create an action and a few axes to handle player input. So before we do this, let's think just for a moment about what we want our players to be able to do. We want our players to be able to move forward and back, and we want our players to be able to look left and right, and we also want them to be able to jump. So moving forward and back, that sounds pretty reasonable, that we would consider that to be an axis, right? Moving forward, say you have a thumbstick pushed all the way forward, then that would go forward, back, all the way back, or W and S respectively on the keyboard. Left and right would be sort of the A or D keys, or left or right on a thumbstick. So we'd want to have that be handled by an axis. The jump, though, that would just be an event, right? You press the button, you jump. Pretty straightforward. So let's define our action first. So we're going to define jump. So to add a new action, we're going to press this plus button next to the action mappings label here. And then that gives us a new drop down. So we're going to drop that down, and we see a new action mapping 1. We're going to rename that jump. When we rename it, it's going to actually drop down a further nested drop down, and this is actually where we define the key binding that's going to be mapped to this action. So the default key binding for jump for this for the purposes of the hover project, is going to be the left mouse button. So I'm going to type left mouse here, and I'm left with just one option, left mouse button. Perfect. So that's exactly what we want. Left mouse button we'll call the jump event in Unreal Engine. Beautiful. Now let's add some axes. So again, moving forward and back is going to be its own axis. So we're going to add a new axis, drop that down, and we're going to call this very straightforward, move forward. As a brief aside here, I did want to point out, you can see I'm actually using multiple words for some of these labels. Move forward, for example. There's no space in between the move and the forward. That is a best practice, so as not to confuse Unreal Engine or yourself later. So just get used to that. If I wanted to be really technical, the best naming convention would be to use lowercase for the first word in a given label and an uppercase for every word after that in an individual label, but I was kind of homeschooled with regards to programming, so we're going to do it my way. Alright, so move forward. We want to map W to actually move the player forward. So here we're going to do, just type W. Then down here under keyboard, we have the W key listed right here. So we select that, and now we have a new thing. We can define the scale. And this says multiplier to use for mapping when accumulating the axis value. That's not very intuitive, but basically what that means is that when the move forward event is called, when we press the W button, what do we want the return value of this event to be? And when we're pressing W, we want the value to be 1. We can multiply this by whatever we want to later. So it's usually, again, a best practice to limit this to something very simple. So when you press down W, the move forward axis returns a value of 1. So that's where we want to leave that. We also, though, we want to be able to move backwards by pressing the S key. Rather than define a new axis for move backwards, if you think about it, moving forward and backward is the same thing but just opposite. So we're going to add an additional mapping for the move forward axis mapping. So we're going to click that button next to the move forward thing, and this gives us another key binding. Basically, that's the way to look at it, is this is another key binding for the move forward axis. And we're going to make this S. So we type in S, we go down to the keyboard, S, just like that. So right now, both of these keys are defined to set the move forward axis to a value of +1. That's not what we want, right? We want S to do the exact opposite of W. So rather than leaving that as +1, I'm actually going to just change this to the opposite of +1, which is -1. So now when we press W, we go forward, or rather, we don't do that yet. When we press W, we set the move forward axis to a value of 1. When we press S, we set the move forward axis to a value of -1. That's exactly what we need in terms of defining or interpreting the player input for moving forward and back. Now we also want to be able to turn left and right, so we're going to add a new axis mapping. So up here in the axis mappings label, we press the plus button, and now we create a new axis. And so we're going to call this turn right. Alrighty, so to turn right, we want the player to press the D key. So we're going to type D here, go down to the D on the keyboard section, and now when the player presses D, we set the turn right axis to a value of +1. And we're going to add another binding, because when we do the opposite of turn right, which would be to turn left, we want the player to press the A key. So we're going to go and find the A key to bind to that, and then again we're going to set the scale to the opposite of +1, -1. And so now we've defined the user inputs for our game, and it's just that easy. So now Unreal Engine, when the player is controlling the PC hovercraft pawn, is going to, well actually rather, it's not connected to the pawn quite yet. Right now, any player, when you press play, if you press WASD, it's interpreting these key presses as events. That's important because here pretty soon we're going to be able to define what happens when those events occur. So to do that, the first thing we're going to need to do is actually make the game use our PC Hovercraft pawn class as the default pawn when you press play. Right now, it's just making you a spectator, which has the exact same control scheme as the editor anyways, so it's not very helpful. So what we're going to do is we're going to create a new game mode that we can use to define the different defaults. Right now, if you go to Project Settings and go to Maps and Modes, your default game mode normally is set to the game mode class itself, and you cannot edit any of the default classes for pawns, HUDs, any of this on the game mode, on the base game mode class. So we need to create a new game mode that will inherit the information from the old game mode class, or the base game mode class. So let's go right click in our content browser, new asset, blueprint class, and right here we can select a game mode, and you can read again all that tooltip information, but basically what it's telling you is that the game mode is going to define the default behaviors of the level, or the default settings for the level that are going to kind of build into the gameplay. So to begin with, we're going to name our game mode Frisbee mode. Okay, that mode that I put on the end of it is literally just for my own convenience to be able to refer to this as, I know for a fact that this is the game mode. Now, of course, Frisbee is going to be because we are going to be playing in this game mode, this first game mode, we're going to be having our Hovercrafts play Ultimate Frisbee. Alright, so I need a home for the Frisbee mode blueprint. I'm going to create a new folder under Content that's just called Game. And I'm going to throw any sort of miscellaneous game required blueprints into this game folder. So let's move the Frisbee mode in there. Now let's edit Frisbee mode. So we'll double click it, and this brings up the game mode, or rather this brings up the blueprint editor. It's exactly the same as this blueprint editor over here for the player character Hovercraft, except for, of course, it has different details over here, different default fields to select from. So with our Frisbee mode, the first thing we want to do is change the default pawn. Right? Instead of having default pawn, we want it to be our custom-made PC Hovercraft pawn. So we're going to select that one. Now I've made a change to a blueprint that I want to take effect immediately, and I want it to save. So I'm going to click Compile and Save, and then I'm going to exit this one. And while we had PC Hovercraft open, it looks like there's an asterisk next to the name. That means that there have been changes made since it was last saved. I'm not sure what those changes were, I don't quite remember, but I'm going to click Save just to be on the safe side, because I kind of like the way that this is shaping up so far. Alright, so now our Frisbee mode game type is set to use our PC pawn, but now we need the editor to know to use our game mode by default. So under Project and Settings, under Project, Maps and Modes, down here under Default Game Mode, now we have a new option. Instead of just being game mode here, we now have a Frisbee mode. So that's what we're going to select. And an important point here is that Frisbee mode, we only changed one value. It really is only different from the base game mode class by one piece of information, and that's the default pawn. Everything else inherited, all of the other data in Frisbee mode inherited from game mode. That's a very important thing, and it's a very convenient thing as well, because what that means is that as long as our PC Hovercraft is not a engine breaking, it doesn't have some kind of bug in it that is engine breaking, we know that the rest of this blueprint Frisbee mode is going to just work right out of the box, because the game mode blueprint just works right out of the box. So that's a very powerful, very flexible and convenient thing, concept for Unreal Engine to use. Alright, so now when I hit this play button, it's going to load up our Frisbee game mode. And because we're using the Frisbee game mode, it's going to make me it's going to spawn me a instance of the PC Hovercraft pawn blueprint. So I'm going to go ahead and test that right now by hitting play. and now I can't move in the viewport. I'm pressing keys and it's not moving around like it was before when I was a spectator. So that's a good sign. That means that something's changed, but we're not quite sure if it's correct. So what I'm going to do is, if you notice up in the viewport, it says Shift F1 for mouse cursor. So I'm going to press Shift F1 and I get my cursor back. And I'm going to go over here to the world outliner while this is still running, right? Pause, stop, eject are my options here, which means the simulation is still running. You can also kind of see the clouds moving. And I'm going to take a look over here and see if I can find PC hovercraft. Perfect. Here is the instance of PC hovercraft that was spawned for me, and it is the one that I'm controlling right now. Now I can see its class defaults right here, which is very good. I'm going to I want to take a look at it while it's in the game world, though, while it's still simulating. So I'm going to do something called ejecting, and that's going to change. It's going to take the player controller out of that pawn. The pawn will stay in the world, but I'm going to remove the player controller so I can fly around the world and I can see what's going on. So I'm going to eject. I'm going to click inside the viewport, and it'll let me turn around in all of this. And there's my player, right there. He's flying in the air, which is kind of disconcerting. I can tell you why that is. It's because we have not set him to handle physics. And so because the game, he basically is non-physics enabled right now. But that's good. That means that our game mode spawning our pawn is working just fine. So now very briefly, I'm going to go ahead and handle some player input. So the way that this is handled is in the blueprint editor, I'm going to, on this tab selector here, I'm going to select the event graph. The event graph is where most of the game logic is going to be located. To begin handling a player input, what I need to do is right-click, and I need to create a node that represents the player input event. So when the player presses this key down in this event graph here, that node is going to fire. So let's start by testing to see if our W key, or actually let's just test our jump action. That's the most simple implementation. So let's search for that. Now we could like browse in this context-sensitive menu for the node that we're looking for, but there's a whole lot, so it's best to get in the habit of searching. So I'm looking for an input node, so I'm going to do input, and now there's a bunch of nodes that have to do with input. So if you remember, jump is not an axis, it's an action. So I need to do input action, and look, I've only defined the one, and it comes right to the top. So I'm going to click that button, and that creates an input action jump node. You can see that there's a few outputs from this node. Pressed is an executable output. That means that when this happens, it's going to fire whatever event is connected to this arrow. Released is another one. When the button is released, it's going to fire whatever's connected to this arrow. And lastly, you have a data output, which is the key. And this particular type of data is not one that I use very often personally. It's extremely useful, but it's a custom-defined key structure for this particular key, for this particular input action. So, as for the purposes of time, given that this is a little bit of a longer video than I expected it would be, I'm going to just do something very simple just to make sure that our input is working. When the key is pressed, I want to execute some command. In this case, a very simple one is going to be just to print a message. So I'm going to type print, and if you take a look down here, there's this thing called print string. For those with little programming knowledge, a string is literally just a collection of characters, letters or numbers. So it's like a text. So I want it to print a string when the button is pressed, and it's going to be, I'm going to change this string. So you can either use the input string as, you can actually take an input into it and it will print whatever string you input there, or you can type in your own custom string there. So in this case, I want to see key structure. No, it's not compatible. All right. So let me go ahead and type in one, pressed jump. And then when I release the key, I want to print another string, so we're going to do that. Print. I'm going to select the print string node here. I'm going to type in my own custom string, released jump. I made some changes, so I'm going to compile this and save it. Minimize the blueprint editor and hit play, and now I'm in my PC hovercraft. I can't move still because we haven't defined movement, but when I press the left mouse key, it says press jump, and when I release it, it says released jump. So the engine is now interpreting our inputs and creating an event based on those inputs, and it's wired to some behavior that the game is outputting to us as well. And that is the sort of the development loop for game design using Unreal Engine. That's all there is to it. Now, it can get a little bit more complicated, but from a base level understanding of how this works, that is it. So in the next video, I'm actually going to wire up the correct behavior for player movement, to actually move forward and back, and look to the left and right, and jump. That one should be a bit more brief now that we have our groundwork laid.